Hello everyone, hope you are having a nice day. Welcome to yet another video for system software. In the previous video, we have discussed about an SIC assembler. And what does an SIC assembler do? SIC assembler converts your instructions into an object code. So we have converted an instruction into object code. Look at the picture shown here. What can you predict from this? See, a girl is going to ATM and she wants $100. So in her mind she wants $100, and if I tell to ATM will not understand. So I have to insert my ATM card. It has to read the chip. I have to give the instruction, and instruction has to be converted to the form where the ATM machine can understand. Only then the dollars or the corresponding amount will be tracked and it will come back to the user. You can understand that. Similarly, what we have done till now, we have taken a program. The program is converted into object code now. Now the program has to be in a form that is understandable by the computer. That is, so when you see a C program, you will easily say that you have something called as header file, then main function, then when that loop is going to exit, which is a last statement. Sometimes it will be a return statement. So you can easily identify that. So similarly, an object program can also be identified. So our lecture goes like this today. So first you know what is an object code. That is, we have converted the object program. You have converted the program into object code. Each line is converted, and the previous class we have discussed that. And now the object code will be converted into object program. So we are going to see that today. And what is an object program? See, object program contains three parts. First one is header record, second one is text record, and the third one is end record. So we'll see that one by one. What is header record, what is text record, and what is end record. First, it's header record. What is header record? See, the first in header record, it starts with the letter H. So the first letter, that is H. Second one will be in position 2 to 7, it will have the program name. So since it is 2 to 7, first position is H, and 2 to 7 means you have 6 letters or 6 spaces to write a program name. So the maximum size of a program name should be 6. Even if it is more than that, in the header, in the object program, you will have only the first 6 letters taken. Then the next one is from 8 to 13. So you have starting address. Starting address, so it's again 6 places. And from 14 to 19, you have the length of the object program. Both the starting address and length of object program is specified in hexadecimal value. So the header record contains 4 things. First one is H, second is program name, then next one is starting address, then length of the object program. Now we'll see that. So the last class we have seen this program. So the program is converted into, so this is your program. The program is converted into object code. Now I am going to write the first object programs line. The first object code line is, see, it's header record H. Then second, the next one should be your name of the program. See, we know the name of the program. The name of the program is specified near the start. That is copy. It's how much letters? It's 4 letters. C-O-P-Y. I'm taking this copy. So the name of the program is copy. So I'll write here as copy. C-O-P-Y. The next, see, it contains 2 to 7. That means this is second place, third, 4, 5. So again 2 spaces are there. So I'll leave the 2 spaces. Clear? So copy, H, copy. Next, I left 2 spaces. Then next one is starting address. So where is the starting address? You know, near copy, start, you will have the starting address, that is 1000. So again it is 6 spaces. So here I will write 00,000. So I cannot specify 1000 because it becomes another number, 00,000. Clear? The next one is after that you have to find the length of the program. How will you find the length of the program? The last address minus first address. The formula is last address minus first address plus 1, because your program starts from 0, 0. So if it starts from 1001, I can say that last address minus first address, but it starts from 0, 0. For example, consider you have an array. Arrays ranges from 0 to 9. I'll give that example, 0 to 9. Once it is 0 to 9, that means how much places I have? 10 places. 0 to 9. 9 minus 0 is 9 plus 1, 10. Similarly, here the thing is 2079 minus 1000. So the answer is 1079. 1079 plus 1, 10. After 7 in hexadecimal 9, after 9 it should be A. So it is 00107A. So it should come like this. That is, you are subtracting it, you get 1079, adding 1 to it because it starts from 0, 0. So 1079 plus 1, it is 1078. This is the header record. So the header record is written like this, H. Then second one is copy, name of the program. So you have only 4 places. The next one is starting address. The next one is your length of the program. Next, text record. See, in text record, the first one, as you know, it should be T, similar to header record. Here it's T. Then starting address of the record, starting address in this record. The next one is length of object code in this record. Then object codes. See, here the first one takes 1 place, second one takes again 6 place, third one takes only 2 place, and the fourth one takes, you can see 11 to 69 means it's 59, 59 plus 1, 60. So you can have 60 object codes. You can have 60 object codes. See, one object code will have 6 spaces. So 60 means you can have 10. In a text record, you can have maximum of 10 object codes. See, when you are writing object program and for text record, the last one is object code. You are going to write the object code. The object code is, each object code is maximum, the size is 6. You remember that 141033, 141033, that means it has 6. Similarly, you can have 10. In a line, you can have 10 because it starts from 10 to 69. That means you have 60 spaces. Then before that, if the length of the object code, I'll teach that. When you are writing that, you can understand. Then starting address of this record, you can also see while writing that. So we'll see the first one. Now consider, I'll write the first one, T. So the first letter should be T. Then next is, what is the next one? Starting address of the object code. See, first I'll show you what we are going to do with this object code. So now listen, the first one is, see, you have 6 object codes. So in the first object code has 6 letters. So I can have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can write up to this one. I can use this in the first record. And the most important thing is starting address. What is the starting address of the first object code? It is 1000. So I have to specify as, first one I have to specify as 1000. So again it is 6 bits. I will represent this 00,000. Clear? Then wait, after that I leave some space for the next one. I will leave 2 space. We will finish that after completing the text record. So I have, what I have to do again, the last one is object code. So you have to specify all the object codes. The first object code, I will copy these object codes here for faster thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will copy this. So we will write it here. The first one. Then I will separate this. the second one, the third one, fourth one, so I'll decrease the size so that it can come in the single line. So next one is, so we'll complete this. We'll use all this here. So we'll bring that in the single line later. So next, see, this is the first text record. See, the first text record starts from 141033 and it ends at 00102D. So here we have to find the length of the text record. See, length of the text record will be calculated like this. So I'll go here. So this is the last one. So 00102D. So it starts at what location? 101B. It ends at 1B, 1C and 1D. So the size is, it is 101D. See, you have to find like this. The instruction starts at 1B. Instruction ends at, it has 3 bytes. So 1B, 1C and 1D. So 101D minus 1000. So again, applying the same formula like length, 101D minus 1000. So you will get the answer as 1D. 1D plus 1, it is 1E, right? It is 1E. So I'll put the value here, that is, it is 1E. So this is the first text record. So the first text record is, we have a text record T, then it is starting address is 1000, it is 1000, then it is 1E, because it is a length, we calculated length like that, then we have written, so you have 60 spaces, I have used all the 60 spaces. So it should not go beyond 60, it can be inside 60 also. So we'll see the next text record, at that time you will understand. See, the next text record is, we have written till 101D, so the next one will be 102D, so next one will be like this. See, here 1, 2, 3, 4, 5, 6, 7. After that you have some memory reservation, and only after 1000 spaces you will go to the next one. So you will write only this 7 text there. So we are not going to do anything. We are not going to fill it with up to 60 spaces. We are just going to use 7 spaces. 7, 6 are 42 spaces will be filled, because after this there is a gap. So we are not going to use the thing continuously. Clear? So next, second text record, we'll write a second text record T. We have to see the starting address. So the starting address there is 101, since it was 101D, it should be 101E. So I'll write that 101E. Then I'll write it bigger, because it is 101E. Then next one is we'll leave 2 spaces, we will complete that after that. So next one is, I'll write the first one. Then the next one. Then I'll write the third one. Then we'll write this one. At last, the 0. Now we have to calculate the length again. So how will you calculate the length? You have to go to the last object code. See, the last object code is 1030. So it has to come from 303132. So it is 1032 minus 101E. So we'll calculate that. The value should be 1032. So the subtraction goes like this. 1032 minus 101E. So what will you do? That is, here we will cancel 3. So wait. So 3 becomes 2 here, and with the 2 I will add 16 because it is hexadecimal subtraction. So 16 minus E. So sorry, 16 plus 2, 18. 18 minus E. What is E? E is 14, right? 18 minus 14. So 18 minus 14, it is 4. So the last digit will be 4. And the previous digit will be 2 minus 1, 1. So you have got 14 as the answer. Clear? So 1032 was initially there. So since it is the last one is a smaller number, I am borrowing 1 from there. So it becomes 2. Once you borrow this, so you have to add 16 to 2. 16 plus 2, it is 18. 18 minus E. E is what? Actually 14. 18 minus 14 is 4. So I got 4 there. 2 minus 1 is 1. So 14 plus 1, because it starts from this location. So you have to add 1 there. So once you add 1, it becomes 15. So the total length is 15. Text record, then 001E, actually the length is, you have to specify in 6. So it's 001E, then 15, then I have specified all those values. Clear? This is how I write the second text record. Okay, so we have written the second text record, and third text record you will write in a similar way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the fourth text record. So what we will do is we'll write it second. The third text record will be similar to the first text record, and you have to do the same operation again and again. So text record will be written like that. So next we will go to the end record. So next one is end record. What is end record? See, end record is it specifies the end of the program. So end record starts with E. The next one is it will specify the address of the first executable statement. So end record goes like this. So I'll write, you'll see that end record, it starts with E. Then what is the first executable statement? So you can see end first. First is the first executable statement. When you see that first, it should specify the address of the first executable statement. First address is 1000. So it has to be specified in 6 bits. How will you specify that? E 00 1 0 0 0. That is, you are specifying that in this. So when a computer or when your SICs look at this, So it will understand this is the starting of the program. So header record, the name of the program, starting address of the program, length of the program. What is the need for length of the program? The program goes till this position, starts from this position and goes till this position. Then all the instructions are kept in the text record. So you have the text records, and 141033 means 14 is for STL, 1033 means RETADR address. So store into linkage register RETADR. It understands. It is all the instructions will be understood, and end record specifies what? This is the end of the program, and your first executable statement was in the line 1000. That means you have executed that. So the program the SIC assembler understands the entire program. So I'll summarize what we have discussed today. So in today's class, we have discussed about how an object code is converted into an object program. For converting that object program, we have used 3 records actually. First one was header record, second one was text record, and third one was end record. Each record has its own format, and we have used the object code in the respective places, and we have formed an object program. Now the work of the SIC assembler is completed. What does an SIC assembler do? SIC assembler converts your assembler program into an object program which is understandable by your computer. So in the next video, we will be discussing about the data structures used by our SIC assembler to achieve this. So a data structure is more important, and we will have a discussion in the next class. Hope you understood the video lecture. Thanks for watching. Thank you.